Hello everyone, welcome back to Math with Allison. Today we're working in our parametric and polar curve series. Okay, so we are moving on to parametric curves. Let's go ahead and dive into it. So we just have examples for today. We already talked about parametric circles and parametric lines. So if you're interested in those two, make sure to see the previous two videos. Now we're just going to talk about curves in general. So here we have an example. We want to parameterize the segment of the parabola y equals 9 minus x squared for x values between -1 and 3. So I'm just going to teach you the easiest way to do this is to just set x or y equal to t. In this case, since y is a function of x, I'm going to set x equal to t. When I do that, y is really easy to solve for. So y is going to be 9 minus t squared. I just replaced x. Now, since I just set x equal to t, this also tells me which t values this is going to be true for. Between -1 and 3, right? Because x is between -1 and 3, I set x equal to t. So now t is between -1 and 3. Now, this is not the only way you can do it. You could try to jazz it up a little bit. So here, if we have x is equal to t minus 1, here we get y is equal to 9 minus t minus 1 quantity squared. I just replace it, right? And now, since I subtracted 1 from t, I also need to subtract 1 from both sides of my bounds, right? So now this is going to be for -2 is less than or equal to t is less than 2. That's the simplest way to do it. Let's try it again. Parameterize the complete curve x is equal to y minus 5 squared plus square root of y. So in this case, it might make it a bit difficult to set x equal to t. Instead, now x is a function of y. So let's go ahead and set y equal to t. That way, this is much easier to solve for. X is then equal to t minus 5 squared plus the square root of t, right? And we want to parameterize this over the complete curve. So we don't care necessarily about specific t values. The only ones we care about are the illegal ones. So in this case, notice that we have the square root of t. So this has to be for t values greater than or equal to 0. Now, if you wanted to jazz it up again, you could set y equal to t plus 5. And the reason that I do this is because we get t squared plus the square root of t plus 5, right? I got rid of that minus 5 plus 5. They cancel out, so we get t squared plus that. Now, again, we need to have positive terms that we take the square root of. So that means t has to be greater than or equal to -5, right? So if you jazz it up, also make sure to change up the t values that you're working with. Okay, let's try our third example. We want to parameterize the piecewise linear path connecting P to Q and then Q to R. So yeah, piecewise. So we have to be very careful about this. Let's go ahead and start with the line segment PQ. So I'm not going to draw equal there. I want my x to be equal to something and I want our y to be equal to something. So let's go ahead and find our slope first because our slope is equal to b over a. So this is change in y over change in x, right? So I get 3 minus 0 over 0 minus -2 or plus 2. So we get 3 divided by 2. So my a value is 2 and my b value is 3. Okay, nice. So now what do we want to do is we want to choose our initial point for the first point, right? So we get -2 and 0. So really we have -2 plus 2t and we have 3t. Now we want to see what t values this is going to be true for. So let's go ahead and plug in t equals 0. That's why we chose P to be our first point, right? Because this works out very nicely. That's going to be our starting position. And then we want to end at Q. So let's plug in t values until we get to Q. So if I plug in t is equal to 1, I end up with -2 plus 2 is equal to 0. And then 3 times 1 is just equal to 3. So this is our P to Q. So this is going to be for t values between 0 and 1, right? Okay. So that's our PQ. It's nothing different than parameterizing just like a normal line. The difference is now we want to parameterize from Q to R. But our t values can't restart. We can't just go back to, oh, t equals 0 and 1. We have to start from t equal 1. So when t is equal to 1, we need to be at our point P. So we know our equation is going to be x naught plus a of t. We know that our y is going to be y naught plus b of t. But we can't set it up just like we did last time, because the way we set it up is we always have t start at 0. So let's go ahead and just start with x. Let's plug in t is equal to 1. So when t is equal to 1, we get x naught plus a. I just plugged in t is equal to 1. And I know I want this to start at my q. So my qx value is equal to 0. Now, when t is equal to 2, that's when we want to be at the point r. So let's plug in t equal to 2. We get x naught plus 2a. And that's where I want to finish at my point r. And that has an x value of 4. So let's go ahead and subtract this equation, right? We'll subtract it from the top equation. So x naught minus x naught is equal to 0. So we get negative a is equal to 4, or a is equal to 4. So we found our a value. We also want to find our x naught. So let's just plug that in here. X naught minus 4 is equal to 0. So x naught is equal to 4. Now we just found our x value. So x is equal to my x naught, that's 4, minus 4t. We can do the exact same thing for y. So let's plug in when t is equal to 1. We get y naught plus b is equal to, and at t equal to 1, we want to be at the point q. So this is going to be equal to 3. Now, when t is equal to 2, we get y naught plus 2b. And we want to, when t is equal to 2, we want to finish at the point r, which has a y value of 0. So let's go ahead again, just subtract this equation. We'll subtract it from the top, right? So we get negative b is equal to 3, or b is equal to negative 3. So we get negative 3t. We also want to find, the starting point. So let's go ahead and plug that back in. Y naught minus 3 is equal to 3. That tells us that our y naught is going to be equal to 6. So here we get our x and we get our y. Now this is true for t values between 1 and 2. So this is our little piecewise equations that we have going on here. We have this guy, right? And this is going to be our PQ, and for t values between 0 and 1. And now that we're at Q, we're going to go down to R. So then we switched parametric equations to the second one, and that's going to continue, though, the T sequence. So we go from 0 to 1, and then we go from 1 to 2. So that's all I have for us in this video today. If you enjoyed it, I have many more like it, so make sure to check out my playlists. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.